Okay. So now we're recording. All right. This is for Physics Fall 22. It is test 1B. It's take-home test 1B. This is part 1. Okay. I got about 15 of you here. All right, so this recording should be, I'll go ahead and put it on YouTube, should be available by 11. So if I go too fast over something, you can always pause it and go back and watch it again or whatever. But since you're live, you should have the advantage, and the advantage is you can stop me and ask questions. So I already have the first two. I went around and looked at all your stuff, and it looked like you guys were getting this. One of the questions that came up, I know on 2A, 2B, was that how do I know that is a positive or it's a negative slope? Because if you're reading 2A, it says slowly at 0.8 I roof meters per second. It doesn't say negative 0.8 I roof. The reason I know it's negative is because it's moving west, and you make the assumption that the default assumption is that anything east is positive, anything west is negative. Okay. I don't know if I said that specifically, but if it's not said, if it's not spelled out, then that's the default assumption. North or up is positive. East or to the right is positive. Okay, for 30 seconds. So take a look at 1A, 1A, 1B, 2A, 2B, and see if you have any questions. And the way we do this to move on is don't do it yet, but I'll ask for a thumbs up from everybody. Just the icon, hit the icon. Not yet, but you'll hit the icon, and that would be okay. We're ready to move on. If somebody isn't, then you either type a question in. Oh, you know what? Daggone it. I thought I covered these, but son of a gun. Okay, hold on. Let me pause the share for a minute. We'll go through and look. Yeah. I want to cover some stuff. Hold on. And then I'll uncover it, but okay. Cover that. All right. Cover that. Okay. Cover that. Good. Yeah, I'll cover that. Because it's recorded. I mean, I can't like go right past it because you'll see it on the recording. You can pause it. I mean, I don't want to I just don't want people just to copy off the thing, you know. All right, so I'll kind of unveil it. All right. Now back to recording, back to sharing. Okay, so cat's out of the bag on 1 and 2. So let me just look at this. If there's anything that last year's. Okay, so notice on 1A, I put parentheses. Here we go. I put parentheses around the whole thing, and then put a J roof on the outside. That's legal. Or you can just put, like on 2A, I put the I roof, and I'm showing you different ways of doing it. So like on the velocity, it's negative 0.8 I roof meters per second T, but then on the initial position, it's 10 meter I roof. So it doesn't matter. Okay, so whenever you ask questions, unless it's something like, you know, you got a booger in your nose, make them public so everyone can see the question. Otherwise, I can repeat the question. And I know it may default on yours to private direct messages, but since we're all here, we're all friends. Okay, so the question was, is it expected of us during the test, take-home test, or during the test in class to draw the dotted lines? Okay, see, that's a good question, but you should have probably just put it public. To form a triangle and label the sides. So these are good questions. Or can we just draw the line? Good question. So that's a stamp question, actually. So the question is, do we need to do this dotted line stuff and color in the right triangle? Unless it says to, sometimes I do want you to color it in. I don't know if it said to here. It didn't really say to, I just, because this is the key. I added that. It's got all the bells and whistles. But I would certainly accept. And on a test, like if I counted off for that, like you didn't put in the dotted lines and the color, and then you come back to me and say, you didn't tell us to, which you would have a good point. So I would have to say, yeah, you're right. So just the line, unless I say so, unless I say in the directions. But, oh, okay. So thank you. That's, I'm glad you asked that question. So look at the blue. The blue right triangle is right side up. The orange right triangle is upside down. And that's at least until about spring break. That's sort of the standard we do. If it's a positive slope, we show it as we do color these in. We'll be doing this probably next week, maybe back at 2, but we color in positive slope right triangles as a positive, as a, you know what I mean by it's not a triangle that's turned upside down like the orange triangle is. Negative slopes are upside down right triangles. Positive slopes are right side up right triangles. But in answer to your question, no, you do not have to right at this point, unless I say on 2A, how do you know the origin? Okay, so that's the question on 2A. How do you know the origin? Well, okay, so it's not given the problem. You look at it, you go, I don't know where to start because it didn't tell me where to start. You had to work your way backwards. That's why in that case, it's probably easier to show, you know, the equation first, then plug in 0 for time. And that's going to give you that's where you get that 10 meters. Okay. If you plug in 0 for time. Well, your question might be, how did you know it was 10 meters? That wasn't given. I think I worked this one last year. I think, yeah, okay. What I did was I said, okay, I know it's 30 seconds. So that sorry, I'm pointing to the screen. You're not seeing me point to the screen. So I see that 30 seconds there. I know that I end up at -14. So I punched that number in. Then I took my slope and worked my way back. When I worked my way back, I got to 10. 10, yes, positive 10. Because, you know, and that's where I got the equation. So I sort of did the graph and the equation at the same time. One helps you get the other, if that makes sense. Okay, hope that answered your question. And I'm showing some work on there. Okay, can we move on? Thumbs up if we can move on. Your little thumbs up icon on your, there you go. 1, 2, 3, 4, 5, 7. Yeah, that's good. Okay, let's move on. Now, number 3, which I've already checked, but let's unveil this. So all I've done here is I've color coded each phase. So, and then that's kind of color coded over here on the writing. So this is different because we've done this. We did we did 3 phases, but it was only 2-dimensional. It wasn't 3-dimensional. When we walked out on the west lawn, we started at Main Street, came back to the South Pole, turned left, walked a little bit, 10 meters, and then we turned right and ran. Okay, but this adds something to it. It adds a Z. Well, it looks like what I said was, I'm going to say in this particular case that east-west is X. So that's different than we were on the west lawn. We were saying north-south is X. But trust me, it changes all the time. Don't think it's set in stone what direction X is. The default is east-west being X. North-south in this case was Y, and up-down is Z in this case. Okay, and it says that on the graphs. So in the first phase, all you're doing there, notice you're asleep in the Z, you're asleep in the Y, and you're only walking east to west. So, so the question you're going to ask is, do we need to show the velocity? The answer is yes. On a test, on a take-home test, I'm not always as specific on instructions, but on a test, more specific on instructions, and I'll give you like conversions. Sometimes if on a take home, you'll do a unit analysis or a gold standard, and it'll talk about miles and everything else, and it won't have any conversions. Well, you have it at home. I'm assuming you can look up, feet in a mile, this kind of things. But on a test, they'll always be there. And if they're not there, if you forgot, you never knew, maybe you're from Europe and you never knew that there's 12 inches in a foot. I'm trying to get better about that, but sometimes I assume too much. So you can certainly ask me, okay? And then I'll tell the whole class. So you'll be the hero. All right, anyway, so phase one, we're just walking west at 3.5 feet a second. West, we're calling negative, so 3.5 feet a second. And then in phase two, notice that you go to sleep in the Y, you go to sleep in the X, and only in the Z. So you can't say you're climbing steps, because if you're climbing steps, you would be awake in the Z axis up and down, and you'd be awake in the X or Y, whichever direction steps are located. See what I'm saying? You're awake in both axes. So you must be climbing a ladder. What did I say? I said you're climbing a ladder at 20 feet per second. Oh my gosh. Okay, you're climbing a ladder at 20 feet per second. That seems a little crazy, but that's what the graph is showing us, I guess. Is that right? 2.0 feet a second. Okay, I was reading my thing. There's no way I'm climbing at 20 feet a second. Okay, so 2.0, that's more reasonable. 2 feet a second. I found that out. I found the slope right here, and the slope is 2. Okay. You go 6, you rise 6 feet in 3 seconds. So rise of a run 2 feet per second. You're not doing anything in the X or the Y. Okay. Now we go to phase 3. It looks like we've reached that 6 foot height. Yeah. So now we stay at that height the rest of the time. And so once I got up to that next level, now it looks like I am going north. Now I'm walking north. This is like a video game, you're watching Mario. And now he goes north let's find out. Oh, he's going north at 2.5 feet a second. That's just the slope. I just found the slope. Okay, so Swargo, you gotta make these public. These direct messages, it helps. Like I need to you need to make all your questions public, just for us. But okay, so Shargo said the object took a lift. Shargo's from Bangladesh, so that was they would call it. They wouldn't call it elevator; they call it a lift. So you could say elevator. You could say climb the ladder. Took a lift. Oh yes. Okay. Then we're on phase 4. Phase 4, you're still at that 6 foot height. And now, and I did notice some of you left phase 4 alone when I came around with the stamps, because now you're looking at it and go, wait a minute. 2 things are happening at once. Looks like I'm going south and I'm going east, but please tell me that I made that so they're equal. Otherwise, we're going to have a problem. We're dropping 10. We're going 10 feet south in 4 seconds. And please tell me we're going for east, we're going -14 to 4. Yeah, good. So we're going 10 feet. We go 10 feet south and 10 feet east. So that makes it a 45-degree angle. That's nice. And on the test next week, I'm not saying every angle in class is 45 degrees, but if this is, and there's a good chance it'll be on the test, it'll be 45 degrees. Okay. I don't want to be throwing a curveball at you. I try not to throw curveballs at you on tests. I take it back. I mean, there's 10% of the test can be a surprise. Not like tricky trying to fool you surprise, but like something we talked about but was not on either take-home test. And usually it's like late stuff we get to. Anyway, that I'll keep to myself. All right, and so this last one, then we are, it looks like a walking southeast. We're walking south and east at 45 degrees at a speed of 2.5 feet a second again. Okay, that was new, sort of new. We done two-dimensional, that we threw in the third dimension. So be expecting something like this. Now, as far as points, this is worth 8 points on this thing. You can pretty much double or triple that for a test. Here's the reason why. Take-home tests, obviously it's worth twice as much total on a test as it is on the two take-home tests combined. Plus, you have half the questions, because the test is still one page front and back, so it's not like it's 4 sides. So you cut the questions in half and you double the points. Now you can, your rule of thumb here is that it's about 4 times. So this probably, if this is on a test, it's probably worth at least 30 points. All right. And question. When writing the possible description, should we use iRoof? I'd love for you to use iRoof. You might even get some bonus on that. I'd love for you to use iRoof, JRoof. That'd be wonderful. Okay, good question. Daggone it, that's another stamp question. So the question was, so you get stamps coming to these things live. You don't get these if you watch the recording. The question was, what letter should I use on the Z-axis? So you go X, Y, Z, I, J, K. So K-roof. K-roof is for the Z-axis. And yes. So Sebastian said I used K-roof on the homework. Yeah, fine, that's good. And how do you get the velocity? That's just slope of the line. All that is slope of the lines. That gives you the speed, and then you got to say whether it's positive, negative. Then you go on. Okay, now I'm talking velocity. Here, okay, so let's go back to that. Let's go real quick. Go to that iRoof thing. So you would say, like on phase 1, let's stick that in. Phase 1. Oh, my colors aren't right, but that's all right. I would say it's walking west at 3.5 feet per second. iRoof. East west is X, so iRoof. You could have also said he was walking at negative 3.5 feet per second iRoof. That says the same thing. Okay, but I've said the word west. So if I say he's walking west at negative, that gets confusing. Wait, he's going west, but it's negative, so he's actually going east. What? So either say he's going west or just say he's going negative 3.5 feet per second iRoof. Climbing a ladder, in that case, you would just put K-roof, and that's positive. Walking north, and that K is like a lowercase cursive K with the roof on it. Walking north, so in that case, give me a green here. In that case, I would say walking north. That's J-roof. Sorry, J-roof. J-roof. Normally I go blue, but whatever. It's really hard to keep colors consistent in physics. And then, phase 4, you put iRoof and JRoof. That's where, and I went through a big, on the description on one of the screenshots today, I went through this long 100-word explanation of like things, vectors going at angles. You got to show it as a component method. You got to, so that's, I'd rather do phase 4 this way. It's so much easier than break it up into its iRoof, JRoof, because you'd have to say, you could do it. You'd have to say it's going, okay, we'll just write it out. No, I don't want to do that. Okay, whatever. Think on the spot here. It's 10 and 4. Did we just find a mistake? Okay, dig this. I didn't notice this last year. We had the same question last year, but I'm thinking that southeast. Okay, let's take a look here. Sorry about this. But you brought it up, man. Southeast, so we're going this way. Okay, so we're going this way at 45 degrees. And it looks like, I think we may have found a mistake. It looks like we do go -10, maybe not. And we go +10. So that is us, right? Oh, so that is for X and Y, where we're at, but that's the position vector or the displacement vector. But if I'm looking at it in terms of velocity, okay, now watch the velocity vector here, and we can talk about this more tomorrow. I didn't expect it to get this crazy, but for velocity, I'm going 2.5 because it's 10 in 4 seconds. So I'm going 2.5 I roof, and I'm going -2.5 J roof. So that's my velocity vector, but that length, that's going to be, we're going to Pythagorean theorem that. Yeah. Okay. So you guys are seeing the mistake I made. So 2.5 squared plus 2.5 squared equals, and then square root that. Yeah, 3.5. You're right. So that's 3.5 feet per second. So that is wrong. Didn't catch that last year. Well, and because that's kind of getting ahead a little bit of where we're at. We just started doing this with Pepper walking that, we didn't even bring up velocity on that today. That's going to come maybe tomorrow. So a little bit ahead here. All right. And I'll go over that again tomorrow with you if you want, because that one, I wasn't thinking on that. Yeah, that's one way of doing it. The other way of doing it is you could also say, well, it's 100 plus 100, so it's root 200 square root, and then divide that by 4 seconds, and that gives you also 3.53. So this guy is like root 200, whatever that, I did that a second ago, but whatever it was. So there's two ways of getting that velocity. I think it's worth going over tomorrow. First person to remind me each class to do that, they get a stamp. Yeah, so Pythagorean's theorem. Now Sebastian said, well, Pythagorean's theorem is for distance. I agree, but you can also use in vectors, you can use Pythagorean's theorem for velocity as well. You could use Pythagorean's theorem for acceleration, which we will get to that, but that's more packet 2. I got 3 episodes of it. Okay. Well, I'm excited now. This is fantastic. Me too. Okay. So are we good on that now? Well, I confused you enough. Okay, let's go on. And this one, oh, I'm sorry. I didn't, yeah, you're all saying, okay, let's go. And you can always, if I'm going on and I'm not seeing your comment, you can always break in with and say something. Cole was the best at doing that last year, which I appreciate. Okay, so this guy here, I feel like I owe you one on gold standard. I am bound and determined to not have this one black. I mean, if there's a black problem, I made a mistake. That means I made a mistake. That's mea culpa. I don't want there to be any black problems all year long. So I'm really going to try to make sure there's no black problems. That means I went too far, or it's such a confusing problem that, shouldn't have ever been asked. Those kind of things. Those are black. All right. So this one, so the point that there is that next week on the test, it's going to be more like this one than it was like the one on the test 1A. Okay. So let me show you the answer here, what I got. And we can we can use this as a key as well. Somebody might copy. Well, you know, that's the thing. You're going to copy this, but then you're going to bomb a 300-point test. So I'm okay with you checking the key out. I want you to. So here was, I should have shown you step by step. I kind of unveiled the whole thing, but as far as points go, this is only 12 points, but remember, we're talking 36 points now, probably 40 points. It's probably going to be a 40-point problem. And in that case, you'd probably get like, well, I keep pointing to the screen, but you'd probably get like, I don't know, 4 for that, 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 at least. And that's 20 points right there. Just getting to the given point is at least half, sometimes 2/3 credit. All right. And so it's weird units. There's always going to be weird units on these. Well, not always. Like qubits is a true unit, but it's like from qubits is the time of Galileo. And then before that, like Noah building the ark, we're talking qubits. So qubits about 1.5 feet to 2 sigs. So here's something else. If I give you the if I give you these, if I give you conversions, you need to use them. Now in AP physics, sometimes they give you conversions you don't need, or they don't give you any conversions at all, but then you get a sheet that has a lot of conversions on it. But I think it's enough to try and get you to understand the idea of gold standard than to throw all that at you. So if I give you conversions, they need to be used. And say you have no idea how to work a problem, but you do see conversions, then stick those in the conversion area. You're going to get some points for that. I mean, you eat, live, and breathe off partial credit in physics. No, okay, that was a great question, Shargo. I'm going to give you a stamp for that. His question was, is it okay if I write miles per hour as mph? Normally, yes. It is illegal to do that in gold standard. Because when you think about it, if you're saying miles per hour, that puts a divided unit inside a cell. And you can't have, and I went over this on some of the help videos, you can't have divided units inside cells. You can have multiplied units, but you can't have divided units. Okay. So you'd have to say one point, you'd have to say, oh, if you leave it as if that's your answer, okay. Oh, I'm sorry. If it's in your answer, yeah. That's fine in your answer. Within the problem, though, you have to break it up into miles and hours on bottom, or if you flip it, hour miles on bottom. Okay. But yeah, Schwager, you're correct. In the answer, you can just say mph. That's fine. Sebastian says it also correct to say velocity equals d over t. You can't. Okay. One thing I know American education does this. We say distance equals rate times time, which is horrific because little d equals r times t. No. R means something totally different in physics. Little d, if you're in calculus, you probably start to learn this now, stands for derivative. We don't use little d often, very often. Seldom do we ever use little d. So it's either, because the one thing, it's not descriptive enough. Is it delta x? Is it delta y? Is it delta z? You know, so would I count off at this time of year? No, but I will, starting in packet 2, count off for saying d when you mean displacement, because you're not being accurate enough. Okay, and never use r for velocity. Does rate could be velocity, rate could be acceleration, rate could be jerk, rate could be snap. So it's got to be more specific than that. So good questions tonight. What else you got? Anything else? Ready to keep going? All right, we're doing okay on time. We'll finish this up. All right, Finn's ready to keep going. Haley says yes. Adam, okay. Well, we're good enough. We have enough people. Let's keep going. Oh, all right. Hmm. I hate just showing you answers. There's really not, there's work here, but if I don't do that though, then I can make a whole nother sheet on a key. I don't want to make a whole nother video. Oh crap. Okay, I'm only showing this if you promise to work these and not just copy down the letters. I went around, I checked, most people had done these. Okay, so let's see if you're right. I want you to know that you're right. I don't want you to be studying the wrong stuff. So there's justification. Here we go. This, I'll give you a minute to look at these. Look at these. If it goes, if you look at your paper, it goes ECCCC BBA, ECCCC BBA, and it probably will look like this on the test. So I do want to see the capital letters. I even ask you that, please. And I'm showing you this. This is now in the video keys, so you'll be able to go back and look at this. But I was trying to color code this so you could see where my work was up on the power line. And that, okay, that's for best way to write. I mean, normally I say better, but kids say, well, it was better. But if it's multiple choice, I'm saying, what's the best answer? So the pink goes with 9, the black goes with 10, the green arrow up there, this green arrow goes with 11, and then the orange with 12. So I'm trying to show you, that's really, you can do it in your head maybe, but you will have the power line. So I see this all the time from students. They show the little jumps. It's just making a big jump, you know, it tells you how far to jump. And this is what we talked about today with better way to write or best way to write. There's a help video on this. I'm coming out with a reference sheet on this probably Friday. You'll have it at the latest Monday. I still got to write that test tomorrow night, so maybe not. Maybe it'll be Monday, but it'll be Monday at the latest. And then you'll probably have like 12 help sheets that you'll get to use. That I'll either give you a paper copy or some way I'll get it to you. The problem with paper copies is that they're not in color. And so much of this needs to be in color. So I'm still debating that one in my head. Questions on 5 through 12. Any questions on best way to write? All right, well, fair enough. Let's keep going then. We can make it. All right. All right, so let's go on to 13. We have 15 total. So this is new. I've not checked this. I expect when I come around tomorrow, you 15 at least will have these perfect. And it's an easy stamp, right? Okay, I changed this one from last year. Yeah, I changed it. It's better this year. So we're starting. This is like us earlier this week. Walking in the down. First, we're starting here in the J. We're ending up in the I like we did. Only there's no angle yet. Now, test number part 2, that'll have the angle in there. But here we're asleep. We're either awake or we're asleep. We're not awake in both axes. So it's not that hard. It's not as hard. So we got the phase 1. And there's phase 1. Where you're starting at the 8J roof meter mark. You're walking at a speed of 0.75 meters a second. So that's going to put you there in, here's my work up here. Let me blow this up. Here's my work for that. Oh, zoom in on that. So with the J roofs, and then I get 10.7 seconds. Now notice a J roof, the J roofs do they always cancel? I don't want to say something that's false. It's a vector divided by a vector. In this case, the vector divided by a vector is a scalar. Time is always a scalar. Time doesn't have a direction. So the J roofs canceled each other on that case. And notice that on the units, the meters, the meter and the meter canceled each other, and you have 1/1 seconds, so seconds came on top. I mean, for physics, the math has to work. All right. So that's the first phase. And then the J roof goes to sleep because now we've exhausted all the J roof. We're at the origin for as far as Y is concerned. And then X wakes up. Okay. And that's this second part. And so the way I found that is I went the same idea. I'm trying to find, I knew where it started, where it ended, but I didn't know how long it took them. That was the one I had to find out. So the delta X here was 6 I roof meters. And once again, I'm still going at 0.75 I roof meters a second. So I divide that, I get 8 seconds. So I end up, I'll show you the whole thing now. I end up at 6 meters in the whole thing. You add it all up. What do you get? About 18.7. You're at 18.7 seconds. Okay. I mean, it's pretty sophisticated stuff. I know it's all not even acceleration involved yet, but we're doing some sophisticated stuff. Shargo said, if I can't show the line when it's sleeping, can I just write dormant above it with 2 dots? Just thicken, just show a thick line there. Okay, I want to see the line. Okay. Maybe when you're drawing with your pencil, you go, well, it doesn't even show up. Just make it thick so I know it. I know, in other words, you have to show me that flatness. Yeah, I'm going to insist on that. Okay. Yeah, keep going. Thumbs up. Still got 15 minutes. We can do it. We'll finish ahead of time. Thumbs up. Did my mic still work? Hello, hello. Are we going? We're going to keep going, or are you guys saying you're not ready yet? You want to stay here?